Hello there, and welcome back to CM4D Basic Training. In this module, we will consider some of the options that separate a data stack from a data set and some major ways in which data stacks are used. So first, I want to show that I have two data sets that are created, DataSet A and DataSet B. Basically, I connected to a query and I picked first 10 points in that query. And just for illustrative purposes, I'm using all the samples. And in these sift rules, I'm just looking at X data for surface and holes for this data set A. So in the end, if I view that in grid, I have 10 rows. Each is X data for one of the features that I picked for the samples that I have in the query. So for DataSet B, I simply right-clicked and duplicated DataSet A, and then I changed the name to DataSet B, and the sift rule, I had it looking at Y data instead of X data for surface and hole. So with that, I have a DataSet A and a DataSet B, where A is looking at X data, B is looking at Y data for the exact same points. So again, it's just for purposes of this exercise as an example. We have two data sets. We can have more, of course, but I'll just stick with those two. To illustrate DataStacks, I'm going to click here in DataStack. I'm going to right-click and choose New Data Stack. If you notice, it says DataSet 1, but the object icon is a data stack object instead of a data set. If you notice, a data set looks like a grid as the object, but a data stack looks like two or more grids superimposed on each other. That's because data stacks, again, perform operations on data sets or other data stacks. It can manipulate data between two other groups of data. So to see that and see what options are different, we'll double click and go into the data stack properties. The first difference, if we look at the general tab between a data set and a data stack, is that there's no sift rules for a data stack. Instead, you have what's known as data stack values. This is a temporary set of spec limits that you can create just for whatever values you're going to contain in this data stack. So you don't have to, you can specify no spec limit, but if you wanted to, you could create a spec limit that has a particular nominal, has an upper and lower spec limit. So this is not in relative terms, this is in absolute terms. This USL, LSL, standing for upper spec limit, lower spec limit. That can exist again for the data that you're going to put in this data stack, and it's a temporary set of spec limits that can apply to it. Sometimes that's used if you're evaluating the information in a particular way, or if you're doing some sort of analysis and you wanted to calculate SPC statistics on them. It would apply to the data within this data stack, but the information would not be saved back into the CM4D database. It would exist locally in the document at this level for the tolerances that you apply, any percentages that come from that, or any nominals that get created within here. So again, that's the first difference. Another difference is here in data source. Typically for a data set, we connect to the left side of this window pane by connecting to a query, picking data from a list or all the features, picking our samples. That's typically how we connect with a data set. Sometimes we also connect with a data set by using this option, DataSet option. So you can have a data set that has another data set as its source of data. But on the right hand side, typically we connect to other data sets or stacks as the source. And the main thing that separates a data set from a data stack is this data stack area. So this is where the actual operations for a data stack appear. Basically, this allows you to do manipulations between two or more sets of data sets or data stacks. For instance, if I go here, there's 4 general types of operations. There's merge, there's 3D math, statistics, and valuation. So to kind of illustrate how this works, I'm going to go to merge, choose append, and the merge operations, you can combine data in specific ways. So one way is append, and the way to combine data is you choose the option here first, then you go to data sets, and here I have a list of the data sets that I created already. I can choose the data sets that I'm going to combine together by moving them over into this left-hand window pane. Once that's done, I can hit OK, and then basically this append operation will happen between these two data sets. So to see what that looks like, I'll choose that option, hit OK, and keep in mind that what we had for the content of DataSet A was X data for 10 rows for those features, and then for B it was Y data for those 10 features. Since we did the append operation, if I view the data stack in grid, it will show me the contents of DataSet A, but then the contents of DataSet B underneath it. So it appends B onto A in order to create a container that has them both. So that's what the merge operation for append is doing. If I change that to collate, then this will effectively shuffle the data instead of append it. So that means I will have the first row of DataSet A, and then the first row of DataSet B, then the second row of A, and the second row of B. So to see that in action, I'll do collate, hit OK, and then now if I look at the content of that data stack, I see that I have the X data for A, then the Y data for B, then the X data for A, Y data for B for row 2, for row 3, row 4, and so on. So again, we're doing a shuffling operation between the rows of whatever data sets you handed. And if I go back to that function and change the order and make it B then A, it will switch this at the top from XY data to YX. So now it's doing Y and X. So the ordering in which you put in the data sets will determine the order in which the operations are taking place. So those are two ways of combining data from two or more sources. If I had more data sets, C, D, and E, I could add those in, and as long as the number of rows and number of columns for all of the data sets are the same, it will continue to add them on. So again, just as an example, I'm going to duplicate B. I'm going to call this C, and I'm going to make this look at Z data. So now if I added that here, I will have X, Y, and Z. Now if I'm doing an append For instance, if I go back to this data stack, go to data source, choose append again, I'll have X, Y, and Z. But let's say that for my C, I don't have the same number of rows. So instead of 10, let's say I get rid of these and I just have 5. Then if I view this in grid, if I'm using the append operation, we can have different numbers of rows between the data sets that we're appending together, as we see here. But if I do a collate operation on this, we'll see if that's the same case. It is, but as you see, it now has gaps for cases where there is no Z value. So 1, 2, 3 here. So in general, it's a good idea that the data sets, when you're doing operations, in some cases, the data sets should have the same number of rows and columns for the operation. Now, if I do a subset, this will take data from all of 3 of these as a subset and then combine them together. So if I choose this option, and then if you notice this new button appears called Setup, I can click on that, and this tells me the start row, which I'm going to use to take data, and then how many rows do I take at once. So if I do 1 and 1, this means that it's going to take the first row of A, B, and C, and only the first row, and put them together. So I'll end up with a data stack that has 3 rows. So that's the first row of A, B, and C. If I change the setup here to start at the second row, it will do the same, but it'll increment just for the second group of data from A, B, and C. And then finally, if I set start at the second row but do 2 rows, it will take the first 2 rows of each one and combined. So there's 2 rows of A, 2 rows of B, 2 rows of C. So it's doing that count. So that is used in very special cases where you need to have a container of data that's a subset from other sources. There's, again, a lot of scenarios that come into play where some of these techniques might be useful, sometimes not, but in general, you have the functions available and you can choose to use them or not depending on the situation and what it is that you need to report. So those are some of the options for doing merge together with groups of data sets. The next option is 3D math. This is where you can do calculations between the values in 2 data sets. So for instance, you have here add, subtract, mean, high, low, range, multiply, divide, and then worst. So if we do add, what this will do is add A plus B plus C. I'm going to take C out for now and just say A and B. And what you'll end up with is a matrix or a list that is the same size as either A or B, but the values for the corresponding rows and columns will have been added together within those 2 data sets. So to see this, I have A and B doing an add. My data stack result is 10 rows with the same number of columns as the samples, but each value here is the sum of the same row and column cell from the other two data sets. So if I look at A, that's 0.49. B is minus 37. So 0.49 plus a negative 0.37 is what would give you the 0.12. And that's the same for each position in this data set. For this one here, 0.85 plus a negative 0.15 gives you 0.7. So that can come in handy sometimes if you're trying to look at a relationship between two adjacent points. Instead of doing add, you could do a subtract. Maybe subtract from two different panels. If you're trying to get a gap measurement between the two, you could put the points in a particular order for both data sets and then do the subtract function, and then in the data stack you would have what the gap would be. That's one example in which an operation like that could be used. Now we have here C, which again has less rows than the other two. What if I added C onto here? What would happen? As you see, the data stack simply does not resolve. And that's because in the case of 3D math operations, you must have the same number of rows and columns so that it can add the corresponding cells together. If that's not the case, then the data stack simply won't resolve. So I'll have to remove C in order for the data stack to compute that operation. So the others are similar. Subtract, it would subtract A minus B. So we'll subtract, it would be 0.49 minus a negative 0.37, which would give you the 0.86. And again, the order of operations would change that math. So if I moved this up and set B minus A, my values might come out different. In this case, it would be negative 0.37 minus 0.49, and that would give me the negative 0.86. So besides subtract, you have the mean. What this will do is calculate the mean value between the three groups, or whatever groups that you have within here. So let's say that I want to make data set C the same size by adding the rest of the points I took out. So now if I go back to the data stack, compute the mean of A, B, and C, it will take this value plus this value plus this value, and then divide by 3 to give you this value, which would be the average between those three corresponding cells, and do that for every cell between those three data sets. So same with high, this would look at which is the highest value between those three cells for each group. So Again, if I chose this cell, so row 10 here, 0.25, 0, 0.12, then that means here I should see 0.25 as the high value, which it is. And of course, if I change this to low, we would get 0 in that cell. So there's low, there's range between adjacent cells, there's multiply, there's divide, and then there's worst. And with worst, what you can do is have each value compared against its tolerances, and whichever one is considered the worst or furthest out of tolerance, that would be the value that shows. So again, in the case of this cell, we have this value, we have -3.7 and -10. So in evaluating those three, looking at the deviation, whichever one has the biggest deviation, that's what would show up here. So again, 3D math, you do operations between data sets. The data sets need to have the same number of rows and columns together. So the next main set of operations for a data stack within this area is statistics. There are a lot of statistics here. Most of them, as you see, are about covering subgroups or process control if you're using that with process control charts or need to look at a particular type of value. But there's other types of statistics such as high and low, range, mean, sum, and in these cases they no longer are about doing comparisons between different data sets, but instead each one is evaluated separately. So if I did statistic high and left out A and B, what this would do is look at each row of the A data set, compute which value is highest on that row, and then give you back that value. So if I do this and then hit OK, what I'm going to end up with is the high value of this row in this column, and then the high value of this, the high value in this row, this row, this row, so on. But the high value of this row 1 would be in column 1, and then the high value of row 2 would be in column 2, the high value of row 3 in column 3. So this is the high value for row 1, high value for row 2, row 3, 4, 5, 6, 7, 8, 9, and 10. So it's displayed in a way that's transposed from what you're thinking. So after you do something like this, we could also use the transpose operation on the data stack to transpose it to look more like what we would expect going from top to bottom instead of from left to right for each of the rows. But in both cases, you're seeing the high value of that particular row from the data set that was in the data stack. So what if we added the DataSet B to this? Well, if we do that, then it will compute the same thing for A, but the same statistic would be for B in the next row underneath. So the first row is for DataSet A, and each column is the high value for that particular row in the data set, and then the same would happen for B. So it computes them separately, but puts them together in a list such as this. And again, if I added C, that would be a third row that it puts underneath, showing the high value for those values. So you can do that for the high value, the low value of each row, the range of each row, the mean, the sum, the count, standard deviation, and then some control statistics like PP, PPK, CP, CPK. In a case like this, it would compute the CPK value for each of the rows and give you the CPK values for data sets A, B, and C, for row 1, 2, 3, 4, and so on for each of the data sets. So again, in a case like this, if I click on the C and then go here to modify data set to go into C, and then change out the number of rows for this operation, again, the data stack does not resolve. So the same case applies here for statistics, where the data sets that you add into it should have the same number of rows and columns. So the last major function of a data stack, if we go back to the properties under the DataStacks section, is the evaluation functions. These evaluation functions allow you to do some sort of summary statistic on whatever data you include in this data stack. For example, if I chose tally, what this would do is generate my statistic for values that are in and out of tolerance for whatever data set I add into this. So if I have this A data set and do tally, hit OK, and when I view this in grid, I'll have percentage intolerance, overall percent, and the number of values here for my tally consideration. So if I go back, there's also tally 2. That's for your second set of spec limits. So the features in CM4D can have 2 sets of spec limits applied to them or created for them. So tally, the first one, can give you percentage of values in tolerance for the first spec limit, and then tally 2 for the second. There are other types of evaluations like score, where you can pick what's known as a score function, which will be talked about in other modules. Scores allow you to categorize the data values that you send to it according to bins that you set up. The bins can be for certain levels of values. It can be based off of variables. It depends on what groups you're trying to put your data values into, depending on the type of data. For instance, you could have a score for CPK values that vary from greater than 1.33 as a bin, and then between 1.33 and 1 as a second one, then less than 1 as a third, and then negative values as a fourth. That's just one way that you could create bins for a score, and then your data values would fall into particular categories. You could assign colors or weight values to those categories. In general, scores are set up in another function area of the software, and then you would pick the drop down and choose the score that you want to use. After that's chosen, you supply it the data set whose values are going to be given to that score, and then the software would compute which values fall into which categories for that score. There's other types of evaluations as well, such as bin, normality, benchmark, but the major ones that are used are ConformanceSummary. This one has a few different setups. Basically, this keys off of what was discussed before about data sets, and also in DataStacks, if you include one of those. There's always an event tab where you can set up logic conditions. In this case, I set one up called out of tolerance. You can have 2 total, but whatever condition you choose and whatever value you supply, whether it's a variable or a number that all the values are going to be compared against. If I chose this out of tolerance, then basically that is the event or the conformance trigger that I've set up for this data set. And then later on in the data stack, if I go back and choose ConformanceSummary and go to setup, I can say, all right, do I want to see the count of the number of values that conform within that data set? Do I want the count of valid values, the count of values that trigger the condition and therefore don't conform? So again, the value I set for that was out of tolerance. So anything that's in tolerance is considered a conforming value. Anything that is out triggers the condition is considered non-conforming. So that being the case, you have a few options for the type of data you want to get summary-wise. So if I chose percent of conformers, this would give me back the percentage of the values of that data set that are not out of tolerance. So if I do that and then go here to data sets and make sure that that one is chosen, it will generate for every sample the percentage of values that were in tolerance. So if I go back and change the setup to percent of nonconformers, I would get the opposite. So 10% for each of these samples is out of tolerance for the data in DataSet A. Now in this case, if I go back and add more data sets, instead of treating them separately, it would take all the values together and give me what the percentage is for the percent of nonconformers value. So if I choose this and then hit OK, because I added more data in from the other data sets, the percentage dropped to a bigger number for values that are out of tolerance. So those are just one of the options here for doing evaluations, ConformanceSummary. Another widely used one are row variables. This allows you to specify a particular variable that you want to use in order to get back values in the data stack. So for instance, if I wanted to know what the mean value of every row is, I could type in tilde mean tilde as the variable, and then what this would do is generate the mean value of row 1, 2, 3, 4, up to 10 of dataset A, and then do the same for dataset B and C and put them in this grid structure here. So depending on what variable you choose, I could also say high value or range. It would compute that for every row and put that in the corresponding cells of the data stack. And then there's also something called DataSet variable that allows you to generate similar information but for the entire data set. So in this case, I could do something like DataSet range. And this would look at all values in DataSet A and give me the highest range between the highest and lowest for each data set. I could also do something like this, DataSet %conform. That's one of the variables that can be used in CM4D. That would evaluate the data set together as a whole and give you back percentages. So now instead of having a percentage per sample like the other method, this gives you the overall percentage of values in tolerance for each of these data sets. So again, there's many different methods to use in order to do evaluations. There's a lot that are kind of beyond the scope of the basic training for this module, but hopefully you have a pretty good understanding of the 4 different types of data stack functions, some of the major operations, and the results of the data when you use them. So again, thank you for attending this seminar. Look forward to seeing you for the next module.